Hey everybody and welcome. We're going to jump into day 2 of review videos here. So we're going to be talking a little bit more today about division. So we've been doing a lot of factoring, but division is kind of a second way to do this. And we're going to go over the 2 different types of division that basically we looked at last year. So long division is one of them. Personally, not my favorite. So honestly, if it's not your jam, don't feel like you need to spend a whole bunch of time on it. And then the second one, synthetic division, this is much more useful in my opinion, so I would say that's probably where you want more of your focus to go for today. So 2 different types of division. We'll jump through some practice questions, and hopefully we'll be feeling well reviewed on these subjects before we start using them for more pre-calc stuff. So example number 1, a squared minus 2a minus 15. We are going to put this into our big house and put a minus 5 on the outside. And what we do here is we just go one at a time. We match up our first with our first. So we match up a with a squared. And basically the question that we ask ourselves is a times what gets us a squared? Well, in this case, a times a. So what we do is we distribute this a to both of those terms. So we end up with a squared minus 5a. So from this step, we've identified a as a term. We take this and we subtract that term from what's given to us there. So in this case, what that means is the negative goes to here, and it also goes to here. So we end up with, after distributing this in, and I'll do this in a different color so it's more clear, plus 5a, and then negative a here. So a squared minus a squared gets us 0, and then plus 5a and minus 2a leaves us with 3a. From there, we drop down any other terms that we have, so minus 15 comes down, and we repeat our process. So we again match up our first term with our first term, and we ask ourselves that same question, a times what gets us 3a? Well, in this case, a times positive 3. So again, distribute 3 to both terms, 3a minus 15. And then our second step here, subtract. So again, that subtraction does go into both terms, so I'll show this again in red, minus 3a plus 15. When we do this, we end up with 3 minus 3 is 0, 15 minus 15 is also 0, so there is no remainder. So after dividing, what we've determined is a plus 3 is what we get when we divide. So if the question here is, well, why would we divide? How is this useful? Well, the 2 terms on the outside are a minus 5 and our a plus 3 multiply together to get what's on the inside. Essentially, this is a really fancy and complicated way of factoring. So we have just factored using long division. So I'll walk through a second example if this helps. Again, same idea. We're basically looking for a factored response. So x plus 2, x squared minus 5x plus 3. So first term with first term. So x times x gets us x squared. So distribute that into both. So x squared plus 2x. And then our next step is we subtract both of these. So we end up with negative x, negative 2x. So the x's cancel, and we're left with negative 7x, and 3 comes down. So again, we match up our first term with our first term. So x times what gets us negative 7. Well, here, negative 7x minus 14. And again, subtract. So plus and plus. And it leaves us with an answer of 17. So this time, we have something called a remainder. So it's not just 0 left over when we get to the end. So how we do this is we add that number on top, and on the bottom, the fraction x plus 2. So this term right here becomes the bottom of the fraction. So after dividing, x plus 2 times x plus 7 with a remainder of 17 over x plus 2. And what this tells us is this does not factor cleanly. There's no way to cleanly factor this, so basically that is kind of what we're stuck with, that remainder of 17. Next, we can move on to synthetic division. This is much more my favorite. The first thing that we want to do with synthetic is make sure we have all of our coefficients, our numbers, clearly lined up. So if we have nothing showing for a number, we want to put those ones down there. So end up with 1, minus 1, plus 1, minus 2, plus 3, and minus 6. So these are all of the ones that we have here. So putting these all out in order, these are just the numbers that we're bringing straight down. The second piece is taking a look at what we have on the bottom. What we have to do, take that and set it equal to 0. So what that's going to do is that's going to solve for x equals -1. So because that's -1, in our little box, our synthetic box on the outside, that's where our -1 goes. So this is our setup, and from this spot, we start the synthetic division process. So the process is always as follows. So number 1, we want to drop our first number down. Number 2, if it's below that line, we multiply it by what's inside of our box. So 1 times -1 gets us -1. Number 3, combine. So -1 and -1 together get us -2. And again, take this -2 and multiply it by what's in our box over here, which is -1. So that gets us +2. And keep going from there. So combine. +1 and +2 gets us +3. Multiply it by our term in the box. Combine -2 and -3. Multiply it by the term in the box. Combine 3 and 5 to get us 8. Multiply it by the term in the box. And we end up with our final answer here. So we have 1, -2, +3, -5, +8, and -14. So we read this from right to left. So we start off with our remainder. So this goes over x plus 1. Our next term is our number. So remainder, number. So just 8. So we leave it like that. And then we start adding in variables. So x squared, x to the third, and x to the fourth. So we kind of count down from left to right. So our full final answer with our remainder is x to the fourth minus 2x squared plus 3x squared minus 5x plus 8 minus 14 over x plus 1. So putting all those things together, that is our final answer after doing synthetic division. So same thing here for our next one. So 12x cubed minus 2x plus 5 divided by x plus 1/2. So a couple of things that we have to do here. The first is we have to make sure we're not skipping anything. So you'll notice here, we went from 5 to 4 to 3 to 2 to, there's just a 1 there. From here, we skipped x squared. So we have to add in 0x squared, because we can't skip anything. And once we've done that, we can now do our 12, our 0, our minus 2, and our positive 5. So once more, take what we're dividing by. So n set it equal to 0, so subtract 1/2 from both sides. And that's what's going to go inside of our box is minus 1/2. Bring our first number down, multiply it by what's in the box, so -6. So we end up with -6 here. Multiply -6 by what's in the box, so cut it in half and change the sign. We end up with +1, and here, +1 times -1/2. So we end up with 4.5 here. So that's our remainder over x plus 1/2. So that's our remainder. Then our number comes next. So our 1 is there, and then 6x and 12x squared. So our full answer here, 12x squared minus 6x plus 1 plus 4.5 over x plus 1/2. So that's what we're looking for synthetic. Line up those numbers and follow that algorithmic process. This one is one that, honestly, it takes a moment to work through the steps, but with practice, it'll get a little bit easier every time you do it. All right, lastly, we have the remainder theorem to use. So for the remainder theorem, what we are going to do is identify if there is going to be a remainder, and second, if there is a remainder, what that remainder is going to be. So if we look at our question here, we are dividing by x plus 2. And we are trying to determine whether or not there is going to be a remainder after we divide by x plus 2. So the first step of what we need to do is we have to take our x plus 2, just like we've been doing, and set it equal to 0. This is going to get us an x equals negative 2. So this negative 2 is going to be the key to determining whether or not we have a remainder. So we take our function, we're taking what we're dividing, and what we do is we actually plug in that negative 2 value. So here we'll get 16. For our next one, when you punch that in, this negative 2 to the second power is positive 4. We'll get minus 12, minus 2, minus 2. And this will get us 16 minus 16, which leads us to 0. So here, 0 is our remainder. So what that tells us is that after we actually divide this, we're going to get an answer that has a remainder of 0. So there's only one way to check that, and that's to actually go ahead and do some of that division. So if we do synthetic division here, we're going to have 1, 0, negative 3, 1, and negative 2. And inside of our box, we'll have our negative 2. So bring 1 down, multiply it by negative 2, multiply by negative 2, multiply by negative 2, and then multiply by negative 2. What we see for our remainder, we actually do, in fact, have a 0. So that told us before even doing this question, we knew that we would be able to divide in cleanly here. So after dividing in, we have our number, our x term, our x squared term, and our x to the third term. So our full answer for this one, after dividing, is shown there. So that can help us basically tell us if we divide in cleanly, then we know that basically it is factorable. And if it's cleanly factorable, then that's going to help us to find our zeros. So hopefully this helps working through some of the examples that we have here. Again, if you have questions, let me know. This is one that takes a moment to kind of remember some of those skills, but hopefully after doing this a few times, we'll be nice and refreshed and caught up and ready to go.